Hello, everyone. In this lesson, we're going to go over the trig function values in calculus. I went through the calculus text and I found, these values of trig function values that you most likely encounter when you are taking calculus. Okay, so the question we're going to talk about is that some of you have unit circle in you. In that case, if you're very good with trig unit circle, that would be a big plus. But I also noticed that many of you do not have trig unit circle in you, or you don't quite remember, or you have hard time and you just don't remember all the values. So this is addressed to those of you who want to find a way to figure out those values without having to take a trig course all over again. So this is what this recording is for. And these are the exercises I prepared for pre-cal class. And these questions in pre-cal class are selected from calculus texts. So I divided these three sets of questions into three groups. And based on these three groups, and I will address how you can find them on your own by applying the three pillars of trigonometry, which are ARD. In this set, of course, I will call it ARD, so it's A to D. Okay, so this is the set that's A to D. So how we do from A to D to find these values. And of course, we're going to talk about what is A, what is R, what is D. Okay, so let's get started. A in trigonometry is about angle measurement. Okay, angle measurement. What does it mean? Angle measurement means that how the input of trig functions are measured. Okay, so first of all, let's list all 6 functions, right? Let's list all 6 functions. Okay, so I'm going to list the sign of an angle. A is for angle for input, cosine angle, tangent an angle, okay, and cosecant of an angle, secant of angle, and cotangent of an angle. All 6 functions, they take angle as input. So angle is their input. So angle measurement is about how this input, all 6 functions are measured. Okay? And of course, the output are ratio, right? The output are ratio. We will talk about those ratios after, when we get to D. Okay? So how is this angle measured? The angle is measured if the angle is positive. Okay? If the angle is positive, and we measure angle from a very specific position. Okay, so this is the place we start to measure angles. If we measure counterclockwise, and that's called a positive angle. So positive angles are measured counterclockwise. Okay, so let me change the font. Counterclockwise. Okay, and the negative angle is measured clockwise. Okay, so if we measure any angle, right, if we're starting from here, right, we measure the angle. So let me show you the measuring of angles. Okay, so we're going to start, suppose we have a line, right, so we start measuring the angle. Starting from here, if we started counterclockwise, right, that will make a positive angle. If we start from the same place and we measure clockwise, that will make a negative angle. We have a negative sign in front of it. Okay, so that's about angle measurement. Okay, all right. So that's about angle measurement, A. And then is R. The second letter is R. R is the first letter for reference angle. What is reference angle? A reference angle is the positive acute angle between the terminal and x-axis. Okay, x-axis. Okay, so back to where we started, right? We measure angle. Suppose I measure an angle starting from, of course, from this place. I measure and I terminate. So this red is called the terminal. This red terminal and the angle we just measured is that piece. Sorry, I need to draw a curve. Okay, I need to draw a curve. Erase. Okay, a curve. Draw. Okay, so let's see what this is. Okay, so this is the angle we just measured, right? And this red straight line is the terminal. Reference angle is the positive acute angle between the terminal and x-axis. So the reference angle is the terminal and x-axis. This is x-axis. And the positive acute. Acute meaning between 0 and 90 degree or pi over 2. So this will be the reference angle. This is the reference angle. Okay, that's called a reference angle. And the actual angle we have here is A. Okay, so angle, reference angle. Sometimes reference angle the same as the angle, and sometimes they're not. Okay, all right. D. Then we get to D. Okay, so we got A, and we got R, and now we get D. Okay, D stands for definition. So D is the first letter of a definition. Definition of all 6 functions. So now we're going to take this, right? So we're going to define what are those ratios? What are those ratios? Okay, so definition, in our definition, we assume, okay, suppose, okay, or sometimes you can use the word let x comma y, okay, let comma x comma y be any point on the terminal side of angle A, right? Be any point on terminal side of the angle A. And it cannot be 0. Okay, so I'm going to put not equal to 0, 0. I will explain. So let x comma y be any point on terminal side of the angle A. Okay. Now, and we are going to define a number called R. R is equal to the square root of x squared plus y squared. Okay. So now let's see how we read this part, right? X comma y is not equal to 0, 0, be any point on terminal side of angle A. What does that mean? okay? So we measure angle from here. Okay, we measure angles. So when we measure these angles, let me make sure you see everything, okay? All right, so when we measure angle and we got a terminal, right? Suppose we got a terminal. We measure from here and we got a terminal. So this is a terminal. The angle we got is right here. That's A. That's A, right? Now, we're going to pick up any point. We're going to pick up any point, okay? We're going to pick a point. And that point can be any point on this terminal. You can pick any point you wish, okay? So let me see if I can make a dot. Spotlight. See what the spotlight do? Suppose I pick a point here, right? I can pick any point here, okay? I think this will do. You can pick the point here, you can pick the point here, you can pick the point here, you can pick the point way up, as long as it's on the terminal. And then you cannot pick up 0, 0, i.e. x and y cannot be 0 at the same time. So you can see the R of so choosing will not be 0 and it will always be positive. So R is positive is implied, okay? R is positive is implied, okay? So now, next, we're going to define all these 6 functions. I'm going to define all these 6 functions, okay? I'm going to take an example, okay? So I'm going to take, so I draw this, we've been using this in class, right? So we're going to be consistent with it. So now I pick any point on the terminal side of the angle. Suppose I pick up this point, okay? So this point, let me see. So this point is a straight line. Let me draw a curve, okay? So let's erase that one. I'm gonna draw a curve. So this point is a point of choice. Okay, this point is a point of choice. I'm going to maybe put a red dot. Can I put a red dot here? Okay. We used to have dots over here. I think, let's see. Select. Okay, so we got a dot. Suppose we put a dot over here. Wait. It doesn't do the dot. Okay. Never mind. I'm just, you know, this is a dot. So this is the point. Okay. Oh, there we go. This is what I was looking for. So this is the dot. Okay. So this point is x comma y. And I'm going to use red and blue. Okay. I'm going to use red and blue. Okay. So this is x comma y, right? X is the horizontal measurement. So we're using red. Y is the vertical measurement. That's the blue, okay? So now we got the point, and this is the R. R is always a positive. So now we can define how is sine equals to. So next, actually, I'm going to mark, instead of x comma y, I'm going to mark it as I'm also going to mark it as I'm also going to mark it as red and blue, okay? So also known as red, let me write red, okay? So that will be red. Red. And the Y is blue, okay, blue. We're going to consistently using red and blue. You can see at the beginning, we have all these assumptions set up. So when I say red, it means the X, which is a horizontal measurement. When I say blue, is a vertical measurement. Okay, so now we're going to go about to do our definition. Our sine A is, okay, sine A is blue over R, okay? It's R under blue. Okay, I cannot make this blue word to be blue because the restriction of the software. Cosecant is reciprocal of sine, so that's equals to R over blue. Right? You can see that if you know sine, you know cosecant. They're just reciprocal to each other. Cosine is red. Well, this can be a red, but I'm going to write it as red over R. And secant is R over red. Okay? Tangent is blue over red. And a cotangent is red over blue. Over blue. Okay? So all you have to do, oh, I'm sorry. Look at this. These are all switched. Okay. Sorry about that. This is just, it's shifting, but you know what I was talking about. Okay. So we got it. So let me erase all of that. Okay. Just these two softwares, they just don't talk to each other. Okay. So now we can see that if you know cosecant, you know sine. If you know cosine, you can find secant. If you know tangent, you can find cotangent, right? So this is one way to find it. So those ratios are then defined, okay? Those ratios are then defined, all right? So the case we want to make here is that if you know ARD, which we just talked about, and you'll be handle all of these values without having to memorize unit circle. Okay, so let's see how that can be done. Okay, let's see how that can be done. So we're going to look at the first group, right? First group of questions, and I have it here. Okay, I have the first group of questions over here. Now, we are going to place ARD. When we need it, we'll come back, okay? So A, R, right? D. Okay. Now, so please write it down. You take notes, right? I'm gonna move forward. So the first group of exercise is the first table. Okay, so I'm gonna put this table on the side, and we're gonna come back to it. On the first table, when we look at sine 0, right? When we look at sine 0, A is the angle, right? So in this case, A is 0. How would we measure angle 0? We measure angle 0 starting from the position of starting measuring and ended on the same terminal. So the red, so if you look at the way we measure, right? When the terminal overlap with the starting line and blue is shrinked to a dot, so we only have red, right? Blue is shrink to a dot, we only have red. And of course, this is x-axis. And we pick up any point, right? By definition, we pick up any point on terminal side of the angles, we pick up any point. I intentionally avoided points that may be on the unit circle, but you can certainly pick up points on the unit circle. I pick up 4, 0. So we got 4, 0. In this case, our red is 4. Our red is 4, and our blue is 0. Blue is 0, right? Red is 4, blue is 0. And sine 0 would be equals to blue divided by R, right? And we know that blue is 0. And 0, we don't even need to find R. R is going to be positive. So in that case, sine 0 is 0. So we measure the angle, and we pick up any point from the terminal, and then we identify red and blue, and then we just follow the definition, and we will find the ratio we wanted. Okay? So let's look at sine pi. Okay? Let's look at sine pi. Sine pi, first we're going to measure sine. First we're going to measure A, which is equals to pi. What is pi? Pi is 180 degrees. Okay, so I'm going to put away that one. That was for 0. And now we're looking at pi, right? When we look at pi, when we measure from the beginning, from the starting position, and we measure pi, this is pi, right? You can see along the way, you have red and blue, red and blue, red and blue, and the red is 0, blue is overlapping with y-axis, and red and blue, and now red only, blue is shrink to a dot, right? So this is the angle pi. So angle pi terminates on the negative side of x-axis. So I pick up any point, and this time I pick up the point. I pick up the point, which is -4, 0. So in that case, red is -4, right? And blue is 0. Blue is 0. If blue is 0, by definition, sine of pi equals to blue divided by R, right? Blue divided by R. So blue divided by R, and R is positive, so this is going to be 0. You don't even need to find the value of R, because you know the numerator is 0, right? So we use ARD, we find sine pi. Continue on the table, sine 2 pi, right? How do we measure sine 2 pi? So we measure sine 2 pi. How do we measure sine 2 pi? Okay, so we start from this position, so we measure pi over 2, pi, 3 pi over 2, pi. So the terminal ended up on the positive directions of x-axis, which is the starting line for any angle to be measured. So we ended up with the same terminal. Okay, so for sine 2 pi, right? For sine 2 pi, the terminal, okay? So for sine 2 pi, the terminal is the same as this. The terminal is the same as 0, right? Because we're starting from here, we measure all around, and we terminate at the positive directions of x-axis, right? So you can see for this angle 2 pi, the blue is shrink to a dot, and the blue is 0, and r is positive, so it's going to be 0. So you don't have to do much of a calculation at all. Now, let's look at sine 4 pi, 6 pi. Sine 4 pi and 6 pi, okay, sine 4 pi and 6 pi. Where does sine 4 pi, 6 pi terminate? Let's do it again. Okay, so this is 2 pi, right? And 4 pi. So 4 pi terminate at the same place. How about 6 pi? 6 pi terminate 2 pi, 4 pi, 6 pi. So sine 4 pi and 6 pi, they both terminate the same terminal. So they are all going to be 0 because they're blue, our blue is shrink to a dot. Okay? Therefore, so let me clean this up. Wait. Cleaned up. Okay? So sine of 4 pi will be the same. Okay? 0 over r equals to 0. And sine of 6 pi would also be the same, equals to 0. Okay? So by this time, we have taken care of all these values, 0 pi, 2 pi, 4 pi, 6 pi, and we're left with pi over 2, 3 pi over 2, 5 pi over 2, 15 pi over 2. Okay? What are we going to do with these values? So let's look at sine 2 pi, sine pi over 2. Okay, I bring the table over, but this time we're going to look at what is the terminal for sine pi, for pi over 2. What is the terminal for sine pi over 2? I'm sorry, for pi over 2, okay? So this time the angle is pi over 2, okay? So how do we measure pi over 2? We're going to measure, okay, from the starting position, and that's pi over 2. So the terminal of pi over 2 overlap with the positive direction of y-axis. At that moment, the red is shrinked to a dot, okay? The red is shrinked to a dot. With that, I pick up any point on that terminal. I pick up 0, 5. Can you pick up 0, 4, 0, 10? Of course you can. So on this terminal, I got red is 0. Okay, red is 0 because red is shrink to a dot. And blue, with my choice of point, blue is 5. Blue is 5. Okay? If red is 0, blue is 5, what will be R? R is equals to root of red squared plus blue squared. Blue squared, right? And we just plug in the number. Just plug in the number. And red is 0. And blue is 5. Blue is 5. Okay? So 0 squared, 5 squared. And that is going to equals to root 25. And root 25 is a 5. So now we come back to do sine of pi over 2. Sine pi over 2. Sine pi over 2 is blue over r. Blue over r. Blue over r. And what is blue? Blue is 5. And r is 5. So that equals to 1. Okay? So let's look at sine 3 pi over 2. 3 pi over 2. For sine 3 pi over 2, the terminal is the negative direction of pi over of y-axis. Okay, so let's measure again, right? That's just for the sake of measuring this. How do you measure 3 pi over? How do you measure 3 pi over 2, right? So I'm going to measure from the starting position, that's pi over 2, pi over 3 pi over 2. So this is the terminal, right? So the terminal is the negative direction of y-axis, and I pick up any point of my choice. So this time I pick up 0, -4. Would that be okay? Of course, as long as it is on the terminal sides of the angle and it is not the origin. And therefore, for sine 3 pi over 4, right, sine of 3 pi over 4, 3 pi over 2, which is going to be red over blue, right? No, sorry. It's blue over r, blue over r, blue over r, right? So for the point of our choice, right? So let me get closer to this piece, right? So in this case, the point I've chosen is 0, -4. So the red is 0, right? Red is shrink to a dot. And the blue is -4. Okay, blue is -4. How do we find r? R, we're going to use the same formula to find r. Okay, and our red is 0, so we're going to plug in 0. Just a moment. So this is 0. And blue is a -4. Okay, -4. So 0 squared is 0. -4 squared is a +16. And root 16 is a 4. Okay, so now I'm going to plug in the blue. Blue is a -4. R is a +4. So the result is -1. Okay, so we found the value for sine of 3 pi over 2. How about sine 5 pi over 2? So let's measure sine 5 pi over 2. So we start measuring, right? Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. 5 pi over 2 terminates on the positive directions of y-axis. So we would repeat this whole process all over again, right? So when we repeat that process, right, so we will get sine of 5 pi over 2. And that will also be equals to 1. So this comes to the, how about 15 pi over 2, right? How about 15 pi over 2? So let me do something here. Wait. Okay, let me clean this up. Okay, I'm going to clean this up. What are we going to do with 15 pi over 2? We just have to figure out where's the terminal, right? So for sine 15 pi over 2, in order for us to conveniently measure, right? So when we see the angle, right? A is 15 pi over 2. So I'm going to do something 15 pi over 2. So what I would do is that I'm going to split 15 pi to 14 pi plus pi. Okay? So that will make it easy, a little bit easier to measure because we'll take 2 divided into 14. That will be 7 pi. Right? And then plus a pi over 2. Plus a pi over 2. Okay? So when we are to measure 7 pi plus pi over 2, it's the same as measuring 15 pi over 2. Okay? So let's start measuring. Okay, starting from here. So that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and add another pi over 2. So this is the terminal. The terminal is the negative direction of y-axis. The terminal is here. You guys follow me? So this process can be repeated all over again. Okay, so this process can be repeated all over again. And that tells us, okay, so sine of 15 pi over 2 is also going to be equal to negative 1. Okay, you can see by focusing on ARD, you get the values you need. You get the values you need. Okay, so now continue, okay? We get to another set of exercise. So this other set of exercise I have put together, which is all of these. Sine pi over 4, cosecant pi over 4, and so on and so forth. Okay. So I'm going to put that table over here. You can see all of these 4 have the same angle, pi over 4. Okay. This is a special angle you sometimes encounter. So angle is pi over 4. Pi over 4. So for angle pi over 4, when we measure the angle, pi over 4 is 45 degrees, or half of pi over 2. That's pi over 4. Okay, so this is the angle. This is the angle, pi over 4. Okay, this is the angle pi over 4. So with that, you can see this is the terminal happened to be the line of y equals to x. What's so special about this line? Well, the output is the same as input all the time. So when you pick a point arbitrarily on the terminal, the input is always the same as output, i.e. the red is always the same as blue. Red is always the same as blue. You can pick any point you want. You can pick any point you want. You can pick your point here, you can pick your point here, you can pick your point here, or anywhere you want. Okay, so I picked 3, 3. So red is 3, blue is 3. Okay, so let me clean this up a little bit. If red is 3 and blue is 3, right? So let's write it down. We follow the definition. Red is 3, blue is 3. red is 3, blue is 3. And what is R? Okay, I'm going to copy that formula R. Okay, I'm going to copy that formula R. And that formula R is red square plus blue square. So I got 3 squared here plus 3 squared here. And that is 3 squared plus 3 squared. So we got 2 times 3 squared in underneath the square root, right? So I see it as 3 squared plus 3 squared. That's 2 times 3 squared. And the square root of, so I got root 2 multiply root of 3 squared. And you can do like 9 plus 9 equals 18. You can go that route if you wish, okay? So square root of 3 squared, that's 3, right? So in the end, I get 3 times root 2. Okay, so now with that being done, right, sine pi over 4 is what? How do I get this? All right, so sine pi over 4 is, let's write down all the definition, right? Blue over R, right? Cosecant is what? Cosecant is R over blue. And the cosine is red over R, right? And secant is R over red. R over red. And tangent is what? Is blue over red. Blue over red. And cotangent pi over 4 is red over blue. Red over blue. You can see all you have to do is just plug in those numbers, right? So let's finish. Let's finish. Blue over R, blue is 3, right? 3 over R, R is 3 times root 2. And 3 and 3 reduced, we get 1 over root 2. And of course, if you want to rationalize it, you can rationalize it, right? Feel free to rationalize it. Okay, so I'm going to omit that. And cosecant is R. R is 3 times root 2 and divided by blue. Blue is 3. So that part, you get root 2, right? And the cosine pi over 4 is red over R. So red is 3, right? And 3 times root 3. So you get 1 over root 2, which is the same as sine pi over 4. Rationalize it if you wish. And the so secant is R over red, right? So you're going to get root 2 again, right? As you can see, this will cover your, most of your values just by following ARD, okay? Blue over red, blue is 3, red is 3, so this equals to 1. And cotangent, red is 3, and blue is 3, so that's equals to 1, right? And of course, you can find tangent by, sine over cosine, cotangent equals to cosine over sine. You can do them that way as well. But here we just focus on ARD. Okay, we just focus on ARD. So that's about using this picture right? So let's look at the next group, which is the last group I have prepared for you. This set is about sine pi over 6, sine pi over 3, so for these values, okay? So first of all, pi over 6. How do we measure pi over 6? Pi over 6 is 30 degree. 30 degree is a third of 90 degree. So if you divide this 90 degree, which is this quarter, into 3 parts, right? That's 3 parts, right? This is one angle, that's another angle, that's another angle. So all 3 provided divide evenly by pi over 6, pi over 6, pi over 6, right? So that you can, that's how you can roughly divide to get pi over 6. But anyway, so I got the terminal for pi over 6. So this is the terminal, okay? So we're going to work on sine of pi over 6. Sine of pi over 6. Okay? Sine of pi over 6, knowing that this is a pi over 6 is 30 degree. So this is pi over 6. It's 30 degree, right? So what do we do? What we do is that we draw a triangle, which is like, you flip this current triangle over, you get the dashed, you got a broken line triangle, okay? So it's a mirrored triangle. On this mirrored triangle, this is 30 degree, and this is another 30 degree, so total is 60 degree. 60 degree. And these two sides are the same. So this angle is 60 degree, and this other angle will also be 60 degree, right? This triangle is called a unilateral triangle. Unilateral triangle meaning all 3 sides are the same. All 3 sides are equal because all 3 angles are equal. Unilateral triangle. Unilateral triangle, you can see if I choose the terminal, I pick a point arbitrarily, right? I pick a point arbitrarily on the terminal, right? I'm going to pick a point over here, right? So I make this line to be 4. I can do that. Because I can pick points arbitrarily, right? So if this line is 4, the solid blue would be 2. The solid blue would be 2. And of course, the broken blue is also 2, right? Also 2. So if this is 2, this is a 4, so blue is 2. Okay, so let me write it down. The blue is 2. And R is 4, right? I chose blue equals to 2, R equals to 4. Because of freedom of choosing any point on terminal side of the angle, right? So I got that freedom. So I got blue is 2, R is 4. Can I find red? Of course we can find red. The red would be, well, we can apply Pythagorean theorem, okay? So the red would be equals to the square root of R squared minus the blue squared. Blue squared. Okay? So now we're going to plug in numbers. I'm plugging the numbers, and r squared, r is 4, and blue squared, the blue is 2, right? So we will end up with 16 minus 4. 16 minus 4, okay? 16 minus 4 is 12. 12 is equals to 4 times 3, right? 4 times 3, sorry. Well, 4 times 3. Root 4 is 2 times, root 4 is 2, so we get 2 times root 3. So we got red, right? So from blue equals 2, r equals to 4, we can find red is equals to 2 times root 3. So now we got, oh, by the way, we don't really need the red. We can find the sine pi over 6, my bad, okay? But we find red, right? We found red, we can use it for something else, okay? So even if we don't find red, by the way, right? We don't find the red, okay? So let me just remove the red and put it somewhere else. Okay, so let me clean this up, my bad. I just get, I get, sometimes we do things not necessarily, okay? So from this triangle, right, we draw the equilateral triangle, and then you understand, right? You got the blue equals to 2, and the r equals to 4. By this time, you use the definition of, you use the definition for blue over r, you already get 2 over 4. 2 over 4. You're done, equals to half. So sine pi over 6 equals to 1/2. You don't need a red. You don't need a red. Okay, we're done, right? Now, of course, we have a table, yeah, right? We need sine pi over 6. We want to get cosine pi over 6. If we want to get a cosine pi over 6, yes, we will need, right? We will need the red. Okay, so for cosine pi over 6, we would need the red. So now I'm going to bring the red back. Okay, we will need the red. Now we can do it, right? We have blue, we have r, and we find the red. So cosine pi over 6 will be red over r, right? And red, we plug in the red, and red is 2 times root 3, and r is 4. So in the end, we get root 3 over 2. So we just reduce the 2 and 4. 2 take away a 2 in the denominator, so we get root 3 over 2, right? So you get sine pi over 6, cosine pi over 6. How about tangent pi over 6? Tangent pi over 6, easy, right? So tangent pi over 6, you can do it by definition, is blue over red. Blue over red. And what's blue? Blue is 2, right? Blue is 2. Red is 2 times root 3, right? We found 2 times root 3. So that one will be equals to 1 over root 3. If you like to rationalize it, feel free to rationalize it. You know how. Now, so we got, let's see, what do we got? Right, okay, sine pi over 6, cosine pi over 6, tangent pi over 6, cotangent pi over 6. So can we get a cotangent pi over 6? Of course, cotangent pi over 6 cotangent pi over 6 is red over blue. Red over blue. Right? Red over blue, and we will get the red. We got the red, right? We worked hard to get the red, right? So that's going to be 2 times root 3 divided by 2. We ended up with a root 3. So from ARD, you get all these values. Let's see what else we need to get. We got a cotangent pi over 6, tangent pi over 6, cosine, cosecant pi over 6, right? And of course, we can get secant pi over 6. Cosecant pi over 6, when I was looking through those questions, I did not see secant pi over 6, but you can certainly find it. Okay, so secant pi over 6. Secant pi over 6 is R over blue, right? And R is a 4. The blue is 2, so that equals to 2. So you can find these values pretty easily from this triangle. You can find all these values. Then we are on to pi over 3. Okay, we're on to pi over 3. So pi over 3 is 60 degree. 60 degree. Okay, so for 60 degree angle, right, we measure 60 degree. This is 60 degree, pi over 3. So the way we handle it, right? Suppose you have this situation, you don't have the work you've done before, right? So you pick up any point on terminal side of the angle. So I'm going to pick up the R equals to 4. Can I do that? Of course I can do that because I can pick any point I want. So I pick up this is 4. If this is 60 degree pi over 3, this will be 30 degree, which is pi over 6. Okay? If this is pi over 6, and I measure another pi over 6, and I let this triangle, red, black, mirror to the other side. So we got this triangle, this big triangle with half broken lines and half solid line. That's a unilateral triangle again. That's a unilateral triangle because each angle is 60 degrees. So this is a 4, and that whole thing will be 4. So the solid red would just be 2. And this broken line is a 4. Of course, we don't really need that part. But now this solid red is 2, and this solid red is 2. Can we find the blue? Yes, if we need the blue, we can find the blue. Okay? So with that much information, okay, so let me do a little bit cleaning up. Okay, so this piece is 2, and that is 4. And now we can go about to find all these pi over 3s. Okay, all these pi over 3s. Let's see, what are the pi over 3s we're looking for? Okay, so let me move this triangle because we'll get to that later. Get the table here. Okay, so we're going to work on the pi over 3s. Okay, the pi over 3. So this is the angle, and that's the terminal. The black line with 4, that's the terminal, right? So we get blue, we get red. We know red is 2. Okay, red is 2. And let me make it shrink a little bit so we can have more things on one page. Can I put this to the top? Can I put this over here? Okay, we can do this. All right, okay. So now we're on to sine pi over 3, right? Sine pi over 3. So the red, so we know the red is let's see. The red is 2, right? R is 4. Okay? Red is 2, R is 4. And what is red is 2, R is 4, and sine pi over 3 is blue over R. So we need blue, right? So we would need blue. Blue over R. So we need to find the blue. How do we find the blue? Right? The blue, and we got 4, we get red equals 2, so blue is equals to Pythagorean theorem, right? R squared minus red squared, red squared, red squared, red squared. And that would be equals to the 4 squared minus red is 2 squared. So we got to that root 16 minus 4, so that's root 12. So once again, we get 2 times root 3. Okay, so now to get sine pi over 3, we just have to, sine pi over 3 is blue over R. Our blue is 2 times root 3. 2 times root 3 divided by R, which is 4. And eventually that's going to be root 3 over 2 found, right? So sine pi over 3. How about cosecant pi over 3? Cosecant pi over 3. Cosecant pi over 3. And that will be R over blue. R over blue. Blue. And that equals to R. R is a 4. Blue is 2 times root 3. 2 times root 3, right? And reduce it, we got 2 over root 3. 2 over root 3, okay? Rationalize it as you need. So we got cosecant pi over 3. How about cosine pi over 3? Cosine pi over 3. Oops. Cosine pi over 3. Cosine pi over 3. That's red over R, right? So red over R. So red over R, red is 2, R is 4. So that's equals to 1/2. Okay, so cosine pi over 3 taken care of. Secant pi over 3. Secant pi over 3. Secant pi over 3 equals to, that's going to be R over red. And R is equals to 4. And red equals to 2. So that will make a 2, right? So secant pi over 3. Tangent pi over 3. Tangent pi over 3. So you can see with the definition, we can obtain any value we want. Tangent pi over 3 is blue over red. Blue over red. Blue over red. Blue over red. So blue is 2 times root 3, right? And red is a 4. No, I'm sorry. Red is a 2. Am I? Yes, red is a 2. So that answer is root 3. Okay, tangent pi over 3, cotangent pi over 3. Okay, cotangent pi over 3. I think I'm ready to get it done. Okay, red over blue. Red over blue, and what's red? Red is 2, and blue is 2 times root 3. And that will be equals to 1 over root 3. All right? So by definition, right, ARD, we have demonstrated to you all of these values. And now we have a last one. Okay, we do have a last one. This last one is sine 2 pi over 3. Okay, so we're only going to do this one because I think you can derive the rest if you need it. Because after all of these exercises is really just all from calculus text. So the last one is, wait a second, wait a second, okay, did I take the wrong picture? Okay, we'll use this one. We'll use this one since I have recorded this much. Okay. Sine 3 pi over 2. Sine 3 pi over 2 is 120 degrees. So it's really 90 degree plus 30 degree. But when we measure, right, when we measure the angle, so this is 90 plus 30. Okay, so this piece is really the terminal. Okay, so so this piece is a terminal. I thought I draw a picture for it. Hold on just 1 second. Okay, allow me. Oh, there we go. Yeah, this is the picture I drew. No wonder. Okay, I thought I drew the picture. Okay, I did. Okay, so I'm going to move on to that picture. You know, drawing these pictures takes time to make it nice. Okay, so now let me just clean this up. So we got this is 120 degree or 2 pi over 3. 2 pi over 3. And the terminal, I choose a terminal with length of 4. So r equals to 4. Okay. So we got the angle. I'm just cleaning up a little bit. So the angle is 2 pi over 3. So A is measured is 2 pi over 3. It's a positive angle, so it's counterclockwise. We got the terminal. Red and blue. Okay, red and blue. So the red is a negative, blue is a positive. However, how do we handle a situation like this? Okay, so let me give you a narrative. For the terminal here, because we know this is 30 degree, pi over 6, this is another 30 degrees. The whole thing together makes 60 degrees. Okay, the whole thing together makes 60 degree. 60 degree, pi over 3. Pi over 3, pi over 3. Unilateral triangle again. So this side, and the whole of this side are 3 sides are identical size, same value. So this side is 4. So the whole thing, the solid red plus the broken red is 4, and therefore the solid red is a 2. If this red is 2, this red is 2. So now we can say red is a negative 2. Why negative 2? Because it's on the negative side of x-axis. Okay, So let me put -2. Okay, so this is a -2. So red is -2. Okay, ideally I should write it as a red number, right? I should write as a red number. -2. Perfect. Okay, the blue is positive. R is 4. Okay, so by this time, we need to find sine 3 pi over 2. We need the blue. So how do we find the blue? Okay, so I have to erase that -2 because otherwise it's gonna shift. But we got the red equals -2, R equals to 4, right? So the blue is equals to R squared minus red squared. Okay? Pythagorean theorem. Pythagorean theorem. Red is 4. Red is -2. So we're going to put a -2. -2 squared is 4. Okay, so we got 16 minus 4, and we got a root 12. Root 12 is 2 times root 3. 2 times root 3. So by this time, we can find the value for sine 2 pi over 3, which is blue over R. Blue over R. Not blur, sorry. Blue over R. And blue equals to 2 times root 3, right? R is 4. So in the end, we are getting root 3 over 2 because 2 take away the 2 in 4. So we got sine 2 pi over 3. I think that's all for this lesson. Thank you for watching.